Okay, let's start with this. So we'll continue with uniform accelerated motion under gravity. And yesterday we had an uniform acceleration. So moment we talk uniformly accelerated motion, acceleration is not changing. It means velocity is changing at a constant rate. First thing that comes to mind, okay, there are three equations A, B, C. I have to use one of the three equations. That's one thing we should come our mind. Second thing, what should we notice here? Several quantities are vectors, though we have not put a bar sign here. This is a vector, this is a vector, A is a vector, U is a vector, A is a vector, and S also is a vector. So whenever these are vector, but in case of one dimension, since in case of one dimension, there are only two possible directions, and we can define those two possible directions only with plus minus sign. So what is important, though these quantities, we need to be careful about the sign convention. That's what the second thing will come to. And I think what is very simple topic, a simple thing you need to understand here. See, if whenever velocity is something like this, velocity is like this at an instance, and if acceleration also is like this, if both are in the same direction, it will speed up. And if velocity is in one particular direction, acceleration is in the opposite direction, what kind of motion it will have? If velocity is one direction, acceleration is in the opposite direction. Jaideep, what kind of motion this particle will have?
Yeah, the velocity and the acceleration are in opposite directions, so it will be decreasing in the positive direction.
No, I think that's again I'll define that point, and that's it's very easy point, and this is how we should tell Jaideep. And then next time you should not have this problem. So whenever velocity and acceleration are in the opposite direction, it will keep slowing down. It will gradually slow down, come to a state of momentary rest, and reverses direction. And so what is the so whenever it slows down, reverses direction. So in that case, there's a particular time it will take to come to a momentary rest. Time taken to come to momentary rest will be equal to u by a, from v is equal to u plus at, and it will travel maximum distance also. What is the maximum distance it will travel? Since it reverses direction, then only the distance is maximum. And maximum distance is travels also, it can very easily can calculate, and you can always keep in mind is equal to u square by 2a. Jaideep, have you understood what I said now? This simple
Yes, sir.
point, yes, it will slow down, but these are all simple related points if we keep in mind. So whenever we have uniform acceleration, at particular instance, there's a velocity and there's an acceleration. So if it is both are in the same direction, it will keep speeding up, it will keep going in the same direction. In that case, it is unidirectional motion. But if velocity and accelerations are in the opposite direction, I'm not using any sign here. If one is taken as positive, automatically other will become negative. I'll come to the sign convention also. So whenever velocity and acceleration are in the opposite direction, it will gradually slow down, come to a position of momentary rest and reverses direction. And time taken to come to momentary rest is equal to u by a, and maximum distance it will travel before it comes to rest will be u square by 2a. And this is something very simple thing, is useful in many cases. Okay, so let's get started. So overall, kinematics, there are only two parts: uniformly accelerated motion, non-uniformly accelerated motion. If it is uniformly accelerated motion, I can use three equations. If it is non-uniformly accelerated motion, I have to use calculus. Only two parts. And when it is accelerated motion, uniformly accelerated motion, choice is between the three. So what we need to do, how do we use this equation? I think every time we solve the question, these are three things I need to do. What are three choices we need to make? So whenever we all this motion applies to two different points of motion, different states of motion. So we need to choose which 2 points of motion this equation is applied. Okay, and when we say u and v, whenever the 2 points, so there is always the motion happens in particular direction in terms of time. So when we choose those 2 points, this is the first point velocity, this is second point velocity. S indicates displacement of second point with respect to the first point, A is the acceleration, and t is the time it takes to move from the first point to the second point. So always when we apply this equation, it applies to 2 different points. And once we are clear about which 2 points we are applying it to, it becomes easier. Some of the people are finding little difficulty. So we have to choose which 2 points of motion I need to apply. Then I have to choose among the three which equation we need to apply. And then we have apply with the sign convention. Always keep in mind, we need to use a sign convention. For example, if we talk about when we talk about the motion under gravity, acceleration is equal to g, and g is downwards. So someone will say, is g positive or negative? G is neither positive nor negative. It is downward also not appropriate. It is directed towards center of the earth. But on the surface of earth, we can say it is vertically downwards. And if depending is whether it's positive or negative depends on choice of sign convention. If I choose upward direction as positive, g becomes negative. But some cases we even downward direction also positive. In that case, g will become positive. The value of g can be positive, negative, and value of g also does not change. Some of people still get kind of doubtful at the highest point when the projectile is at the highest point, g becomes zero. No, as long as there is no other force acting on the particle other than gravitational force. Since the force is equal to mg, it will always have an acceleration equal to g directed towards center of Earth. And this acceleration is due to gravitational pull exerted by Earth on that particle. So these are three things. If you just keep these three in mind, rest all is simple application. Okay. So here also, see, moment we have an upward projection. If we throw a ball vertically upwards, it becomes one-dimensional motion, because whenever acceleration and velocity are along the same line, its direction will remain along that line. It becomes a 1D motion. If it is upward journey, so we are taking a case when it's projected vertically up with the speed u, and v is of course downwards. So immediately notice they are in the opposite direction. That's what we thought. And it will keep slowing down, and slowing down, if anything slowing down will come to a velocity will become zero. So it will come to state velocity of zero means momentary rest, and then it reverses direction. That's what happens. And when it slows down, it will take a particular time to come to a point of momentary rest. And time is equal to velocity by g. It will take time u by g, and maximum distance is equal to u square by 2g. That's something, again, we'll go through that point here. The upward journey, it will gradually slow down. Because during upward journey, velocity is upward, acceleration is downwards. That's why it will slow down. And after it start falling, then both are in the same direction. Velocity becomes downwards, acceleration downwards. So downward journey, it will speed up. Okay, and when we say we typically take g as 10, what we understand, every second upward journey, it will slow down by 10 meters per second. So after 1 second, it will become u minus 10. After 2 seconds, it will become u minus 20, and so on until it reaches the top point. And when we talk about time of ascent, I'm going very slow here. So when we have to calculate time of ascent, and do we understand what is time of ascent means? But the time it takes to reach the highest point. And what does highest point mean? Highest point means the displacement is maximum. That's the highest point. So if your ds is maximum, displacement is maximum, then is the highest point. And if s is maximum for a particular value of time, s will depend on t. So ds by dt has to be 0. It means velocity has to be 0. So we know that point already. So when we talk about time of ascent, which 2 points, time from where to where? So which 2 points are relevant here? 2 points are, we are calculating time from this instance to this instance. So these are the 2 points to which I need to apply. So I have identified which are the 2 points. One point is point of projection, and other point is the top point. And what do we know about this top point here? We know that velocity at this point is 0, and it is happening at time is equal to t. I call time is the time of ascent here. So very slowly I'm doing it, and so that we are very clear. Which formulas I have identified 2 points. I have already chosen the sign convention. Only thing I have to use an equation. Velocity u and v are known. Time is relevant here. We have to use first equation, v is equal to u plus at, and arrive at expression u by g. And just to understand here, see, this is something I think some of you can easily understand here. If speed of projection is 30, it will take 3 seconds. If speed of projection is 40, it will take 4 seconds. If the speed of projection is 55 meters per second, it will take 5.5 seconds. So every second is reducing by 10. So moment I look at the velocity, I know how much time it will take to reach the top point, or what is the time interval for which it will keep moving in upward journey. Okay. Okay. Other thing what we notice, if we plot a VT graph of this motion, how would the VT graph look like? VT graph will look like something like this. The slope of VT graph is equal to acceleration. And acceleration is, if we're using this sign convention, is equal to minus 10. So I have to draw a line which has a slope of -10. And it'll start with the velocity, initial velocity at time t is equal to 0 is equal to u. It will look like this. And from here, and this is the time, this time is equal to ta, time of ascent. And what you notice here, so distance travel in last t second of ascent. So this is something, so suppose from here, so this time interval is t second, this is last t second of ascent, and this will be t second after the reaching the top point. These two areas are equal, and this is a simple and important property. And just we can keep in mind, it's not a memory point here. Distance travel in last t second of ascent is equal to distance travel in first t seconds of descent. So whatever distance it falls, that's we can write from ET graph. Another thing is you have some just to this is a point which helps you understanding gets better. What is the speed 1 second before it reaches the highest point? So at t time it reaches the highest point. What will be speed of the particle at t is equal to ta minus 1 second? At 1 second before, its speed will be equal to upwards g. It will be g upwards. And 1 second after it reaches top point, it will come downward g. So what will velocity t seconds before reaching the top point? It will be equal to t minus t into g. This is something I think is pretty simple things, but this I'm just mentioned this point here to just clarify your thought process and give you better insight into this. Right. What is the maximum height reached from point of projection? Suppose I have to calculate what is the maximum height reached. I have to again follow 3 steps: 2 points, which equation, and sign convention. Maximum height is what? If this is the motion which is happening. So maximum height with reference to what? So we are talking maximum height reached. Always when we say maximum height reached, it is reckoned or it is calculated from a particular point. So here it is not mentioned. It is always from the point of projection. From point of projection. So basically, I am calculating which 2 points here: maximum height, ds by dt, v is equal to 0 with respect to point of projection. So this is the point I'm interested in, v is equal to 0. Now, maximum height is equal to displacement. Displacement between these two instances of motion. These are the two different points to which I need to apply one of the equation. Unlike previous camp, I'm now interested in displacement here. So I have to use equation which has S term here, and velocities are known. This velocity u, velocity of projection. Here velocity is 0. This is special about this point. Okay. So all I need to calculate is from displacement from here to here. And if I use which equation, I have to use equation B here, H max, and we easily find u square by 2g. Other thing also, not only that, other thing what you need to understand here, during this travel, suppose it is here, and at this point upward velocity is u1. From here, what is the maximum height it will reach? So any particular point of motion, if velocity is upward equal to u1, from that point it will reach a maximum height of u1 square by 2g. It is valid for any particular point of motion. But in that case, I'll calculate the height also from this point. So this is a point you have to keep in mind. If velocity is u, then particle reach a maximum height hm with respect to that point. Then we can also talk about time of flight. And what is time of flight? When it's projected from horizontal ground, is you throw the ball vertical up. The time of flight is time interval from the ball, the instance you've thrown the ball till the time you catch it again. So if you press the stopwatch is equal to 0 as soon as you project, and as soon as the ball returns to the same point and you stop your stopwatch, you look at the reading. The reading is a time of flight. What is time of flight? From the instance of projection to which time reaching the same point. Again, the ball has to, a projectile or particle has to come back to the same point. So if I want to calculate time of flight, which 2 points, which is the second point? This is my first point and this is my second point. So what is the special of the second point here? The second point also is, if I take this as my S coordinate displacement, the displacement is 0 between this point and this point. So I easily calculate time of flight, which comes equal to 2u by g. Okay. Third point, which is very important, and I'll use it many times, is what is average velocity. And this is true only in case of uniformly accelerated motion. If average velocity between, whenever we talk about average, we are talking about average between 2 instances of time. And when we have 2 instances of time, it means particle is at 2 different positions. First initial instance, where if the velocity is u, and final instance velocity is v. During the time interval, average velocity will be equal to mean, arithmetical mean of the two. That's sign. Okay, and that's how we can calculate. So if I have to calculate maximum height, there's another way I could have calculated maximum height. Here the speed of projection is u, and this point velocity is 0. So between these 2 points, from here to here, what is the average velocity? Average velocity mean of the two. Average velocity is u by 2. And if time of ascent is ta, the maximum height is also can be written as u by 2 into ta. This is not a formula. This is just to make you understand one more way. How do we calculate distance traveled? And some of the questions I will use this here because I feel this is an additional tool you can use in solving some of the questions. Any formula so far? No. All three basic formula. Entire chapter, basically, we normally don't have to go beyond this formula. This only is all questions can be solved using this basic equation. All right. So let's come back to some more simple things here. And in case of object is dropped from a height h. So let's say this is time t is equal to 0. Object is here. It is at height of h. If I drop it, it means initial velocity becomes 0. Basically, u is equal to 0. Whenever he release from rest or drop it, that's what it means. And from here at time t is equal to 0. And let's say it hits the ground at time t. So this is when it stopwatch, it reaches this point in time t. What will be the height from the ground at time t by 3? So if I take what is the t by 3, what will be its height of ground? How do I calculate? This is something very simple question. Only point what I'm making here is see this, and this also is a very small tool which is useful in quickly solving some questions with better understanding. Starting from rest, whenever we drop an object, if we take a time t is equal to 0, at the instance the object is at rest. Okay, if we take t is equal to 0, if I take this equation, u becomes 0. So displacement is equal to 1 by 2 at square. In this case, I have taken from here downward direction is positive. Please note downward direction is positive. Hence, g also becomes positive. Acceleration becomes positive. G also is positive. So what I notice here, displacement is 1 by 2 gt square. Or displacement is proportional to square of the time. So since the time has become 1/3, whatever distance it has moved in time t, it has moved distance h in time t. It will move distance h by 9 in time t by 2. So what is the height here? Height from the ground will be equal to 8h by 9. So this is something, if I understand this point, it gives me better mental clarity. Some of the questions I can solve much faster with better clarity. Okay, that's what I need. X will be h by 9. Had it been t by 4, it would be h by 16. So height would be, the height from the ground would have been 15h by 16. Had it been t by 2, if it is t by 2, it would have fallen distance of h by 4. So height from the ground will be equal to 3h by 4. Okay, Anish?
Yes, sir.
Very simple, no
Yes,
issue,
sir.
no
No
problem.
issues.
Okay, now let's come to some numericals. Okay, a body is thrown vertical ground with the speed u, and it reaches a maximum height h. So from here it is thrown. So at t is equal to 0, if I draw a figure also, and this is also similar to previous question. I'm just saying how do we apply what we have done in the previous case in this case here. It is thrown the speed u. It reaches a maximum height h at time t0. Question is what will this height at time t0 by 2? How do we calculate? So can we apply something previously what we had done in this case, and can we solve it much faster? Let's see this another. You can solve using formula also. You can apply. See, all cases, all such question is using 2 points. I apply a formula between this point and this point first, and then apply between this point and this point. I can get an answer. But I'm looking at is there any other way also of understanding and solving this question? What I'm going to use is slightly different here, other than formula approach. So so what happens here? What has happened from 0 to t by 2? It has reached this point, and from here it has taken how much further time? From red dot to this point, it has taken further time, not by 2. So what will happen after it has time not? It has reached here. So what will be its position at time t is equal to 3 t0 by 2? In t is equal to 3 0 by 2 means it has fallen for a time equal to t0 by 2, it will come back to the same point. So whatever distance it has risen in time interval t0 by 2, same distance it will fall in time t0 by 2. If I understand that part, rather than calculating this distance, let me calculate what is the distance. Rather than calculating what is the distance it will rise in last t0 by 2 of its ascent time, what is the distance it will fall in time t0 by 2. Total time it will take from here to it falls a distance in time t. In t0 by 2, it will fall a distance h by 4. And if it falls in t0 by 2 h by 4, from here also it would have this distance is nothing but h by 4, and hence this height is 3h by 4. Rhea,
Yes, sir.
have you understood this point?
Yes, sir. Understood.
Understood. No? So you can do, so rather than calculating rise, we can calculate fall. We can make it easier. Fall is directly proportional to square of time. So I have just converted time to rise into time to fall. What distance in equal time, reckon from time, what during the time it has risen, if same time it falls, it will come back to the same point. So position at time t0 by 2 will be same as its position at time t0 by 2 during its descent. So h will be equal to x will be h by 4, and hence the time. So I can, this is something, see, this is makes sense. Position at equal time on either side of highest point is same. So position every t0 by 2 total time. What does t0 by 2 indicate? T by 2 indicates time it has taken to reach the maximum point. So what is position at t by 2 minus small t indicate? This indicates his position 3 seconds before it reaches the highest point. And what does this indicate? It indicates his position 3 seconds after it has reached its highest point, and these two positions are same. So sometimes knowing this is useful, and it helps simplify some questions. Okay, and otherwise also you can answer on that. All right, next question. And today, as I mentioned, I know most of you will not get enough time to solve questions later on. So today, I expect all of you to keep solving as we go along. Okay, so keep your pen and pencil and whatever, pen and paper, and keep solving. And you will look, we'll come across some questions that are so simple, pen and paper is not even needed. Let's look at this. I'll go a little slow so that all of you have time to solve. As soon as the questions come on the screen, start reading and start at least attempting to solve it. A particle is projected vertically upwards from A. Most question I have drawn a figure. If figure is not given, you should be able to draw a figure. Okay, it's projected from point A. It takes time t1 to reach a point B. So it reaches point B at time t1. And t1 is not the highest point, so it means it will continue further moving up. So this height kind of path it has taken. At this time also it keeps moving up. It reaches the highest point and again start falling backward and hits the ground. So what are things given here? So it continues to move up. It takes further time to reach the ground from point B. So from here, so A to B, time taken is t1. From B to C and back to A, time is t2. What is the height of point B from the ground? So can someone tell me logically how would you solve without putting pen to paper? First, what is the method I'm going to use to solve the question? Which is the important point I need to make a note of? What does T1 plus T2 indicate here? What does T1 plus T2 indicate? In terms of some of the known figures, none of the known figures of time of ascent, time of flight, maximum height. So T1 plus T2, what does T1 plus T2 indicate? See, T1 plus T2 is nothing but time of flight. So T1 is time from here to here, T2 is for the remaining part of journey. So indirectly in this question, time of flight is given. So if time of flight is known, I can find out speed of projection. Because time of flight is related to speed of projection. If I find out speed of projection, I can find this h also. If u is given, time t1 is given, I can calculate displacement in time t1. So clearly that's what this approach of this question is. From P we can find u, and from u we can find h. And clearly in this question, t1 plus t2 is equal to capital T. Is this approach clear? Jaideep, is this clear? You can easily solve this question now.
Yes.
So, and this is something I leave it. It's fairly simple. So when time of flight is known, speed of projection can easily be found. This question, I can get the value of u, and after I get the value of u, I can find this value of h using my standard equation for displacement in time t1. So there h can be evaluated from this equation. So I will not solve this question here. This is fairly simple. This is only to make you think how to approach a question. Okay, and this answer we get here. You do some simple questions here. The body is released from the top of tower of height h meter. So this is something. See, the figure may not be given in the question. In all question, I have drawn the figure for your convenience and for speed. Otherwise, we'll end up taking too much of time. Release from top of tower of height h. This is the top of tower. From here, it is released. Release means, basically, at this point, speed is 0. That's what release means. And after 2 seconds, stop and then instantaneously released. So it is step point B. It is stopped here and again released. And so again start moving downwards. This question is, what is the height after next 2 seconds? So this is if this is equal to 0. This is what how would it look like? This is where the ball will be at t equal to 2 seconds. What it asks, this is equal to t equal to total 4 seconds. From here another 2 seconds. What we need to calculate this height. Can anyone answer this question without putting pen to paper? And actually, this question is so simple, you can do without putting pen to paper. And in this case, wherever all question take GS step. Can we answer this question without putting pen to paper? Yes.
Sir?
Can you answer this question without putting pen to paper?
Without putting pen to paper, without putting pen to paper, I'm not sure. Sir.
Not sure. No? So just think. Let me see. Let me just go through. See how do we do that? And say some of the questions are, because some questions are so easy. Mains also will come across questions which are very easy, which can better be solved. This speed is u. What is the speed at point B before it is caught? Tejas, you only tell me.
It'll be 2G, sir.
It will be 20.
20 meters. Yes, sir.
And what is the time interval? 2 seconds. What is this height?
Yes,
can
sir.
I calculate easily calculate this height h?
Yes, sir.
Either I can calculate 1/2 gt square, or I know the average speed is 10 for 2 seconds. The height will be 20
Yes,
meters.
20 meters. Yes, sir.
So second part is, as it moves from B to C, soon after it's released, what is the initial spot is velocity at B when it starts falling again? Is it 20 or is it 0?
It's 0, right, sir? Because
Yes. So when it is stopped and released means at this point again the velocity becomes 0. So at this point it is 0. What is the velocity at this point here?
Again 20 meters.
What is this height will be from here to here? 20 meters.
It'll be again 20 meters. Yeah.
20 meters. So what is the h value? H minus 40. So is this something you could, should we not have answered this question without putting pen to paper?
Yes, sir.
So this is something you can think of. See, my purpose today is this particular topic has only those 3 formulas. As I mentioned, we have to apply this formula using those 3 steps. Which 2 points? Which equation? Will sign convention.
Yes.
Only I'm doing it. I'm just putting it. What is the other way we can understand a question? So this is something, if you understand different ways, more ways you understand a question, you have different ways of solving, and you can solve some of the little tricky questions better if you have better clarity about different ways of solving. So what is this question about? Stopped and immediately released means what? Stop, whenever the question involves stopped and released, it changes the velocity to 0 again. That's what this word stopped and released imply. Okay, next one. A ball is thrown vertically up with a certain velocity from top of a tower of height 40 meters. So this is something, again, like most questions, I have drawn a figure. And in fact, all of you should practice to visualize on your own or draw the figure yourself. Thrown at the top of a tower of height 40 meters. This is a tower, and let's say height is 40 meters. It is thrown up from here. And again, always somebody may question, it will come and hit this tower again. Just assume it is thrown from the just side of the tower, so that it is downward direction also it can move. Top of tower. At 4.5 meters above the top of tower, it speed is exactly half of that it will have at 4.5 meter below the top of tower. What is the maximum height reached by the ball from the ground? This is the question which is given. Right. So I need to use this formula between 2 points. What is the first thing which should come to my mind? This is how the ball goes. Okay. So this is how the ball goes. I like it. Looks okay. The ball it goes like it hits the ground. Question is, what are the information given and what are things I need to use? Sorry, I think H max what you need to, if you calculate this height, I can add 40 meter, I can get the total height also. Which 2 points should I use to apply the formula? Whenever to solve the question, I need to identify 2 points to which I need to apply. And then I come to which formula. Since information is given related to these 2 points here, a point which is 4.5 meter above the tower, and is given another point which is 4.5 meter below the tower. So I'll mark those 2 points, and since information is given related to those, I will apply. So these are the 2 points which are relevant here. What is this height from here to here? I'm not writing this is 4.5 meter, and this also is 4.5 meter. And what else is given? See, either whether I take upward direction or take downward direction, speed is v only. So I have taken downward direction also, it is magnitude only. So in this, if this velocity, what is given here, if this velocity is v, at a point which is 4.5 meter below the point of projection, this velocity is twice of that. Okay. So this is what is given here. And if this velocity v, if I take another point at b here, which is in the upward journey, see both upward journey and downward journey happens along the same line. It's only for our sake of clarity we show it like this. Don't question, don't ask me why this is acting a different line. And it's along the same line. So if it is v here downward, it will also be v. Okay, at particular height, at the same position, direction velocity changes, magnitude remains same. I apply between these 2 points. That's a sign convention. What else is given? The distance between these 2 points is given. This will always be initial point, and this will be my final point. In terms of time sequence, this happens first, this happens later. So I am applying between the two. What else is given? The distance between 2 points is given. So actually, what is the displacement if this initial point and this is the final point? This is the displacement, 9.0 meter. Okay, this is what is information which is given here. Pritam. Okay. Vrinda. Pritam is not attending my class tomorrow. Vrinda. Let me keep making note. Vrinda also not attending. Okay. Gayatri.
Yes, sir.
If I ask you, what does this particular part indicate, Gayatri, here? And see, if any of you don't hesitate, even if I am not looking at answer it right or wrong. Okay. See, this is something. So, the moment you call, you don't start feeling, oh no, I don't know the answer and all. So that doesn't matter. Just whatever you know, give it your best try. What does this part indicate, Gayatri? Why I put upward sign and plus sign here? Do you think it has any significance here?
Sir, it is velocity upwards, velocity.
Not velocity. I have taken upward direction. All vectors are positive. So what are vectors involved? Velocity is involved. Acceleration is involved. Displacement is involved. Every case, anything upward is positive, downward is negative. So it has moved from B to C. Can you tell me what is the displacement from B to C? Gayatri, have you understood why I chosen these 2 points B and C?
Yes, sir.
So I have chosen those 2 points because this information is given related to those, and I have just used exactly half of what it would be at 4.5. So if this velocity is 2v, this is b. So I'm going to apply equation between those 2 points here. So is the displacement known here? Can you tell me what is the displacement if I apply the equation between b and c? Not sure? Okay, so you're not sure what the displacement is. Okay, let me ask some other people also. Hemant, can you tell me what is the displacement between those 2 points?
Yes, sir.
I'm asking displacement. The formula is not about distance. Formula is only about the display. All quantity I mentioned in the beginning, all are vectors. Okay. So I'm asking very specifically, I'm asking displacement.
From B to C or A to C?
Yes, B to C. Would I
9
ask
meters.
why I would say B to C? Why would not I say C to B? Tell me. When I will
Because the
calculate displacement,
direction of motion.
yeah, direction of motion. Very good. That's why I wrote an initial point. It has direction of motion. So if I say this will be the velocity at B will be U and velocity at C will be V, I'm following this one, all of you.
Yes, sir.
So that's why when you apply this formula, what does it mean? There's something initial, there's a final, which happens in the terms of time sequence, which happened first is initial, and time sequence which happens later is the final one. So tell me what is displacement here?
9 meters.
9 meter. Okay, Meghna.
Sir,
Yes, what is displacement from B to C? No idea? No?
no, sir.
No, okay. No?
Yes, sir. It's 3v squared by 2g.
You tell me, is the displacement based on this question, is the displacement between B and C is known or we have to find?
I mean, we can use the equation of motion and find.
No, this is also not correct answer. No problem. This is something we'll come to say why, and then you see later why I'm asking you. You see later why did you not spot that answer? Okay, let me ask some Nishita. What is displacement?
Yes, sir.
Can you tell me what is the displacement between B and C? Jaideep, what is the displacement from B to C?
-9.
-9. That's the correct answer. And is that difficult question, Pranav?
No, sir.
Why we have chosen point B and C? Because information is given about those 2 points. And we have to make use of the information given. And we now tell me why it is -9?
Like we consider the downward direction as negative.
Yes, from B it is not moving upwards. From B it has moved to C in the downward direction. We have taken upward direction to be positive. So this is something why I have taken so much of time. So unless you understand how to apply this equation, B cannot be the final point. If we take B and C as 2 points, speed as B is equal to U, initial velocity. Velocity at C is equal to final, sorry, not speed at B. Velocity at B is value of U here in the equation. Velocity of C will be V. And from B to C displacement, this sign will be S value. And time it takes from B to C is T. The T is the time interval here. T is the time interval. Meghna, is this understood now? Meghna.
Yes, sir, I understood it.
So, and would you have any problems? So this is something, this question, we just applied those 3 equations properly, and it's easy to solve. We have those 2 equations, let's apply now. All these questions are these 3 things, which 2 points to use is easy to identify, and then sign convention, and let's apply it now. Okay, I'll erase it off, and there's something less. Now we can apply and find what is the equation we get here. If I use this equation, which equation I'm going to use? Because this point is V and V. So what are things I know? I know velocities and I know the displacement here. So I have to use an equation which has velocity term and displacement term. Displacement is equal to 9 meters. So which of the equation have initial velocity, final velocity, and displacement? Equation B. Hence I'm going to use this equation. Let me put the value here in place of V, which will come. The velocity at point C will come is equal to 2V square. Equal to V square, and given the sign convention, G will be negative. Understand that point also. I have taken upward direction as positive. So all quantities here, U, V, A, and S. If it is upward direction is positive, downward is negative. So G also is negative, and displacement -9 also is negative. I get the value of V square is equal to 9G. I get the value of V square is equal to 9G. So if I get V square is equal to 9G, so tell me, at this point also, I know the velocity will be V. If V square is known as 9G, can you tell me what is the height it will rise from point B? What is the height, further height it will rise from point B? I'm not looking at anything else. So what is this point B? Velocity is known. Magnitude of velocity is known. What is the further height it will rise from point B? Yeah, can you tell me what is the height it will rise from here to here? For any particular point, if speed is known in a vertical upward direction, what is the height, further height it rises to?
3 meters.
No,
V square by 2g.
V square by 2g. No, that's the height it will rise here. So what is the further height it will rise above B? Because you understand why I taken B here. B also is same point in the upward journey. So at this point also, what is value of B? B is equal to, at this point, is equal to root 6g. That's value of B. From this point, it will rise a maximum height of square of this velocity by 2g, and which will be equal to further height from B will be equal to V square by 2g is equal to 3 meter. From this point, it will rise 3 meter, and this is equal to 4.5 meter. This is equal to 40 meter. So what if I have to calculate total height in the question? I think in my answer sheet also, I noticed I've missed that. I've written 7.5. It should be 47.5. This is 40 meter. This is 4.5 meter, and this is 3 meter. And so what is the maximum height will rise? It will be equal to 47.5 meter. Dhanshri?
Yes, sir.
Is it all points I mentioned in the question, all points are clear or not?
Yes, sir, they're clear, sir.
Well, classically, those are minor points, but you notice some of you go wrong. And I don't blame you, but there's something, if you don't know also, yes, that's a fact today. And if you don't know, you have to make an effort to understand now at least. Okay, next question. First, read the question. Again, see what mistake I have done. Mistake, I think there's no choice here. All cases are drawn a figure. The moment we visualize a figure, I think actually half the work is done. The ball is projected upwards with a velocity of 20 meters per second from the bottom of the tower. It basically means just from the side of the tower. And this is the tower here. It is projected here, and this speed of projection U is given here. Value will be, so you substitute later, which is 25 meters per second. And a boy standing on the top of tower, you can imagine sometimes when you're playing on the terrace, the ball falls, somebody throws you vertically up. The ball goes like this. When it's going up, you're not able to catch it. But again, it will go up, it comes down. And the boy, again, from B to C, again, it passes. So any point during its path, any point, it will cross twice. Okay, it crosses twice. And what is given here, when the boy is standing on the top of tower, is unable to catch the ball and it passes him in the upward direction. He catches the ball again 3 seconds later. What we need to do, we need to find the height of the tower. Okay, just scratch this one. I have written this one. We need to find this height of tower H. And you know, this question, this is what the question is. We need to find the height of tower. So can we solve this question without point to? We can solve this question in a lengthy way and all, but can we solve, can you name and tell me how to solve this question without putting pen to paper? It's such a simple question. Can you tell what is the speed V here? Can anyone tell me what is the speed V based on the information given without any calculation? G is equal to 10. What is speed V here?
15.
15. Excellent. Very good. Who said this one?
Yeah, sir.
Yeah. Why it is 15, Shia?
Because it takes 3 seconds.
3 seconds. Basically, if it refers to this point, it has taken 3 seconds. It means time of flight with respect to B is 3 seconds. So this speed is 15. Excellent. So that's one question. And this is something here I don't do anything here. So time of flight from B to C, again, this is 3 seconds. It means this velocity has to be 15. Moment this is 15, if I know this is 15, I know U is equal to 25. Can I calculate this height now? Can I put it without putting pen to paper? What is the distance between B and point A, point of projection? How much time it will take to reach from A to B? Here, can you tell me what is the time it will take to reach from A to B? How do we tell how much time it will take to reach from A to B? Avirup, tell me what is the time it will take to reach from A to B?
1 second, right? Sir?
1 second. The answer also takes 1 second because 25 it has become 15. From here to here, the time taken is 1 second. And what is the average speed between A and B, everyone?
You can just take the average of both the
Average of the two, 25 and 15. What is the average of 25 and 15? Again, does it require pen and paper or without pen and paper?
without pen and papers.
Without pen and paper. That is 20, is it not? Average speed is 20, time is 1 second. This height will be 20 meters. That's as simple as that. Did we get the answer without putting pen to paper? Yes. So that's what the time of flight at the boys level is equal to 3 seconds. And 3 seconds, while the time of flight is 2u by g, it means if the speed is 50, for 1.5 seconds it will go up, and 1.75 seconds it will fall back. So this gives 15, and if it is 15 and this is 25, and since the speed drops at the rate of 10 meters per second during upward journey, the time interval has to be 1 second. If time interval is 1 second, what is the average speed? Average speed is the mean of the two speeds at the two ends, 25 and 15. This is 20 meters, and 1 second is time interval. That's why upward velocity at y position is 15 meters per second. Between A and B, or time taken to reach from bottom from B is 1 second with average velocity of 20. Or you can use the formula. Okay. Yes.
Yes, sir.
Do you think this question is easy to solve without pen to paper?
Yes, sir. It's easy to solve.
Easy to solve. And this is something I hope you have, all of you, some of you following what I'm saying. And you can solve other ways also. And if we try to solve normal pen to paper, yes, still we can get an answer. But they'll also need to again follow the same sequence, which 2 points I choose. Okay, so I assume velocity v here. I use the formula from 3 seconds here, time of flight. And you can do that. You can arrive at the answer. Okay. Next question. So all of you read this question, and I'll give a little time to all of you to think and how to solve this question here. Okay, anyway, this question is a little lengthy one, so let me go through. From top of tower, all of you try and visualize what is given in the question. For this case, I have not drawn the figure. So all figure, you need to figure out the figure yourself. So can you figure out what this question is about? This is given here. First thing what we need to do, we need to mental or actually draw a figure. 3 cases. Okay, it is side like this. First case. From the top of a tower, I have drawn a tower of a height h. And from the top of a tower, a stone is thrown up. It reaches the ground in time t1. So it is thrown with some speed u, and it travels a path. It hits the ground in time t1. That's what is given. Height of tower is h. Then we have second case, and in this case also, I have to choose a particular direction. I have chosen upward direction to be positive. Okay. All cases, this first case is thrown up. Second case, the velocity is given downward direction. Third case, u is 0. But if I choose this initial point and the time it falls, the time interval is related to this point and the point on the ground. All cases, displacements are equal. So T1, T2, and T3, all 3 cases, what is changing is u is changing, displacement is same. And this equation, what we need to apply with appropriate sign. That's the first point we need to keep in mind. So all 3 cases, u will change, but displacement, if I take upward direction is positive. This is the time sequence of motion. This would be my initial point, and this would be the final point. Hence, when you look at the displacement is from the initial point to the final point in terms of arrow. Displacement will be downwards. As all 3 cases, displacement will be equal to minus h. In all 3 cases, acceleration, gravity, which also will be minus g. That's what we need to do. And since this involves displacement and time, this is the equation I need to use. I need to use equation in 3 cases. One equation for T1, second equation for T2, third equation for T3, and then you have to solve equations. So let's start solving. First case, when it is projected vertically upward, since I have taken upward direction as positive, u is taken as positive. I'm using first equation. So in this case, which equation I'm using? This equation, C equation. What is displacement? As minus h equal to u is positive, n is t1, and g is negative. G is downwards. We are taken upward direction as positive. That's the equation. That's the first case. The second case, it is same speed in the downward direction. So in this case, what will happen? Here the u was positive, here u will become negative. Rest all will remain same, and time it takes to reach from here to here is t. So this equation, u is equal to minus u. Only thing changes, in place of u, it has become minus u, and t, it has become t2 square. And what is the third case? Third case, it is released from rest from C, from the same height. So here u is 0. These are three equations. And this equation, if you have to find relationship between T1, T2, and 3, what I need to do here, from these two equations, I have to eliminate what are the two things which are not required. I have to eliminate u as well as h. Rest all is solving equations. One way of eliminating u, I want to eliminate u here. First equation I multiply by T2, and second equation multiply by T1, and I subtract. I eliminate u. I get the value of h. I have substitute h in the third equation. I get value of T3 in terms of T1, T2. So that's the approach to solve the question. The reason why I've taken up this question also is so that you understand the sign convention better and how things are changing in these three cases. Okay. Yes.
So why is it t cube in every equation, sir?
Why?
Why is it
Sorry,
t?
I think this might typo here. All are t square only. Okay, this typing it all t2 square. Okay. So this is like it. Okay, so this is something I hope rest of you can easily solve. So once we get the value of h, substitute h here, we easily can solve this equation. Okay, this next question. Again, I give you maybe a minute or so for you to all